This is Mr. Beck Does Your Homework. This is physics homework number 25, questions 9 and 10. An object is 21.5 centimeters from the surface of a reflective spherical Christmas tree ornament. 21.5 centimeters is where the object is, so that is the distance to the object is 21.5 centimeters. The spherical Christmas tree ornament has a radius of 4.09 centimeters, so my R equals 4.09 centimeters. What is the apparent position of the image? Answer in units of centimeters. Well, if I think about this, this is going to be a mirror problem because I have a reflection in the mirror. But this Christmas tree ornament is going to be a convex ornament. It's going to push out this way. So I've got some object over here. I have my lens that's curved this way, so I'm going to have a focal point here and a 2f here. So this is going to give me a virtual image, just like I always have in this sort of curve of a lens, of a mirror. The radius is 4.09 centimeters, and I know the radius is where 2f is. So my f is going to be 4.09 divided by 2, but since this is a convex mirror, it's going to have a negative focal length. So whatever this is going to be negative some number, 4.09 divided by 2, so 2.045. So this is going to be the centimeters. This is going to be the focal length as a negative focal length because it is a virtual image. So if I were to draw some array diagram here, I would go in parallel, and this thing's going to bounce off as if it came from F. Another rule would be in through 2f, out through 2f. So I could come in through 2f and out through 2f as if I came from 2f. So what I'm going to wind up with is a smaller virtual upright image in there somewhere. So what is the apparent position of the image? I'd better wind up with a negative number because real images would form on this side. Virtual images form behind the mirror. So now I could do 1 over di plus 1 over dou equals 1 over f. My f is negative, whatever half of your radius is. Your di is what I'm looking for, and your do is going to be, for me, 21.5. So now you can solve for f equals. So, oh no, not f equals, your di equals. So that'll give you an answer for your distance to the image. So you take your focal length, you inverse it, you subtract your 1 over do. Remember, since this is negative already, you're going to be subtracting even more. So be careful that you do that correctly. So this will be a negative number minus some more, and then that answer, invert it, will give you your distance to the image. Now it says, what is the magnification of the image? Since it is real image, it's going to have since it's a virtual image behind the mirror, it's going to have a positive magnification. Also, since this is up and this is up, it's going to have a positive magnification, but it's smaller, so my magnification is going to be somewhere between 0 and 1. So it's going to be greater than 0, but it's going to be less than 1. So my magnification is going to be somewhere in there. It's going to be a positive number between 0 and 1. And to find the magnification, it's going to be negative di over do. Is going to be my magnification. So I'm going to get a negative number here. Negative, that would make it positive, and that divided by a positive number will give me a positive number for the magnification, somewhere between 0 and 1.